Hi, my name is Arpit. In this video, I am going to demonstrate week 7 of our electronics lab. This experiment is all about testing comparator, that is 74LS85, adder, that is 74LS83, and 7 segment display driver IC, that is 74LS47. So this is my official ID, and let's proceed with the experiment. So this is week 7 of our digital experiment. So in this experiment, I am testing 3 ICs, that is comparator, adder, and 7 segment display driver. The IC name is comparator is 74LS85, and adder is 74LS83, and 7 segment display driver is 74LS47. So let's proceed with the comparator. So as you can see in the picture diagram, this is a 16 pin IC. Pin 8 is ground and pin 16 is VCC. Here A0 to A3, that is input binary data, and B0 to B3, that is another input 4-bit binary input data pins. These 3 input pin number 2, pin 3, and pin 4, this is cascade input pin, and pin 6, 7, and 5, these pins are cascade output pins. So let's jump to the physical and test this comparator. So as you can see, I am connected this pin number 8 to the ground, this pin number 16 to the VCC. So let's check pin 8 is connected to the ground or not. Yeah, it is. And pin 16 connected to the VCC. Yeah, it is connected 5 volt. And now B0 and B3, I am from B0 to B3, I am giving a binary input, fixed input, that is 9. So in binary, that is 1001. So let's check B0 and B3, that is VCC, and B1 and B2, that is ground. So let's check B0 pin number 9, it is VCC or not. Yeah, it is VCC. Pin number 1, it is VCC, and pin number B1, that is 11, it is ground, and pin number 14, that is B2, it is ground. Now I am giving a input, that is 9. So let's check pin number 10, that is A0. So it is connected to VCC. Pin number A1, that is connected to ground. Pin number 13, A2, that is connected to the ground, and pin number A3, that is pin 15, that is connected to VCC. So now there is 2 4-bit input, A0 to A3 and B0 to B3. So both input I am giving to the 9. So according to the functioning of the comparator, I am getting the output of VCC from pin 6, that is 5 volt, and pin 5 and pin 4, that is 0. So let's check. So now pin 5 is 0 and pin 7 is 0. Now you can see pin 6, that is VCC. So A is equal to B, that's why I am getting the exact output. I am getting the VCC on pin number 6. Let's change the value and set A input to the 0. Now it's A is smaller than B. So let's now I am getting the output from the pin 7. So that is VCC, and pin 6 and pin 5, it is 0. So as you can see, that is VCC, this is 0, and this is 0. So it's clearly defined that our comparator is working fine. So let's jump to the adder part. So this is the adder part. So this is the 16 pin IC, that is 74LS83. So pin 5 is VCC and pin 12 is ground. In this IC, there are A1 to A4 is 1 4-bit binary data input, and B1 to B4 is another 4-bit binary data input. So and C0 is always connected to the ground, and C4 is carry out, and sigma 1 to sigma 4, that is the output of this IC that goes to the 74LS47 7 segment display driver. So in this IC, let's proceed with the physical experiment and see what the way I am connected. So I am connected this pin 5 to the ground, and I am connected this pin 5 to the VCC, pin 12 to the ground, and C0 is connected to the ground. For A1 to A4, I am giving a 1 value, that is A0 is VCC, and A3, A2, A4 is grounded. And for B data input, B1 to B4, so for that B2 and B3, I am connected to the ground, Right now I am changing in when I go forward this experiment go forward in the this experiment, and b4 and b1 is connected to the ground. So when I am giving the input of a0, that is 1, so now I am not getting any from the C4. So let's check. I'm getting any input output from the C4. Yeah, now I'm not getting any output from the C4. So because the A input is 1, that is 1 0 0 0. So that is 1, that's why I'm not getting any input. And what is the output of sigma 1 2 and 3? So it is same like the input I am giving to the a input. So let's check sigma 1. So I am guessing the sigma 1 is VCC, that is 5 volt. Yeah, as you can see, the sigma 1 is 5 volt, and all rest sigma 2, sigma 3 and sigma 4 are 0. So let's check sigma 4. What is the value of sigma 4? As you can see, that is 0. And let's check sigma 2. Yeah, it is 0. And let's check sigma 3. Yeah, it is 0. So, and let's change to the b2 and b3 to the VCC and see what's happened. Now in that case I am getting the output from the C4 or not? No, I am not getting any output from the C4 until our A input is more than 9. So let's set to the A input to the 10 or something 11. So right now I am setting A input to the 15 and see what's happened. Now, and I am getting the VCC from C4. As you can see, I am getting 5 volt from the C4. And let's check the sigma values, all sigma values I am getting or not. So yeah, I am getting some sigma values. That is 0, that is 4 volt, that is 0, and that is 0. So as you can see, right now I am getting the value from C4 because the A input is more than 9. That's why I am getting the output, and I am connected B2 and B3 to the VCC. Now it's become 6. So as you can see, C4 giving me 4 volt output. So it's clearly defined that the adder is working fine. So let's test this 7 segment display driver IC, that is 74LS47. This is a 16 pin IC. Pin number 8 is ground, and pin number 16 is VCC. Pin 9 to pin 15, that is output of this IC that goes to the 7 segment display through resistor. And pin 1, 2 and 6 and 7, these are a 4-bit input of this IC. Pin 3 is the lamp test. Lamp test used to set all 7 segment of the display by lighting them up. And BI pin used to turn off all the segments. It means blank all the display. And RBI, that is used to support a leading 0 with cascade multiple 7 segment display driver. And so let's jump to the physical experiment and see why it's working fine or not. So I'm connecting A to the 0, D to the 0, and B to the 0, and C also 0. So as you can see, all 4-bit I connected to the ground, and as you can see, I am getting the output from the display, that is 0. So let's connect it to the VCC, that is A pin to the VCC, and I am getting the output of 1. So let's connect it pin B to the VCC and see I am getting 2 or not. So as you can see, I am getting 2. So it means the 7 segment display driver is working fine, and our for checking our display is working fine or not. So let's remove all this and check through the lamp test. So I am connecting pin 3 to the ground, and all the 7 segment display LED is glowing, as you can see. So it clearly shows our 7 segment display driver and 7 segment display both working fine. So this is a week 7 of digital experiment, and thank you so much.